Hello again, this is the second video for this week of the course, and in this video we're going to look more specifically about number and learning number. Now, number in the junior secondary school is built on what kids have learned at primary school. Now in primary school they do a lot of number, and it's sort of seen as foundational. It's not the only thing they do, but they do a lot more number in primary school than you will do in secondary school. And that's outlined in the curriculum. And again, the curriculum's online. I'm sure you've all had a look at it and worked your way through it. And it outlines all the areas that you need to cover. But one thing you've got to remember is when your students enter your classes, they'll come with all sorts of knowledges and skills in number, and attitudes and fears and aspirations, confidences, based on what they've experienced before in primary school. And if you get them in that first year of high school, it's almost a chance to reset on some of those things. But some of them will already be set in their mind that they are not very good at maths. And often it's based on something they've done in number that they didn't do well in. In fact, often I would say for about 70% of them, it will be because they say they couldn't learn their times tables. Now we can have a whole debate about times tables later, but you need to know that these kids are coming into your class with a range of things. They don't all turn up the same. And in fact, some of them could well be more advanced. Some of them will have a good conceptual understanding, but more likely that some of the ones who are advanced will be really good at skills and procedures, but probably don't have a good conceptual understanding. So you need to deal with all those things. And the point is here, you can't just assume that just because you've got a grade 7 class, that all of them are the same. If you've got a grade 7 class, you could have kids in their numeracy and number knowledge and skills, anything from grade 3 right through to grade 8 or 9. So today I'm going to look a little bit at some of the background ideas about number, and in your tutorials you'll look at some practical ways you can help students overcome some of their shortcomings. It's really important that you help students catch up if they're behind. Now, the reason I say this is because if a kid's behind when they already come to you and you don't catch them up, then they're going to be behind the next year and the next year and the next year, and they'll never ever catch up. And in fact, they'll struggle to learn a lot of stuff in maths because they've just got so many gaps that they haven't got the conceptual background to be able to do it. So if you have kids turning up who are below the level that's expected of a grade 7 or a grade 8 or whatever the class is, then I would make it my mission to make sure they catch up as early as possible. And that might mean every time you come to a topic, do a little bit of backfilling first so they can catch up and keep going along. This can be really difficult because remember, the kids still have to learn all the stuff for that year they're in, as well as catching up on the stuff before. Now, it's not impossible to do, but it requires you to be really intentional. And what it means is you can't just say, I'm teaching everyone the grade 7 syllabus straight down the middle, because those who are already advanced will be bored to tears, those who are a bit behind will be lost, and in fact you'll only end up teaching maybe a third of the class. It's just not an equitable thing to do. It's not your job as a teacher. You've got to teach all the kids where they're at, and they'll all have different things. You can't treat them like they're all the same. All right, so what is number sense, first of all? Number sense is about being comfortable and familiar with your numbers, being able to use them and feel confident in what you do. So you need to have understanding of number meanings, and particularly larger numbers and small numbers and how you can work with those. You need to know you need to know about the relationship between numbers. So some obvious ones are even numbers and odd numbers and things like that, or multiples of 5 and multiples of 10. Again, they're fairly easy ones to do, but there's lots of other ones you could see. The relationship between division and multiplication, or the division between addition and subtraction. You need to know about the size of numbers. And you need to know the effects of operations, what operations do, and we'll talk about that a little bit in a minute. McIntosh said it's about having an at-homeness with numbers. Now, to be fair, a lot of kids are okay with this outside of school. They are at home with numbers because they see them all the time. The only time they're not at home with numbers is at school, because all of a sudden it becomes fearful and difficult and something that's foreign to them. It seems abstract to their normal life. So your job is to help them to feel comfortable and at home and knowledgeable with numbers, and connecting to what they do at school to what they might do outside of school and around in their everyday life. So why do we need number sense? Well, this is a quote from Zevenbergen, Doller and Wright. They said, and they're famous researchers from Australia, students with good number sense are able to see numbers in a range of combinations and groupings. So they can work with numbers, they can play with numbers, they can fiddle with them, they can feel comfortable moving them around. It's not just they know that the numbers are, they know how they can be pulled apart and put back together, how they can be used to make things happen. To develop advanced number concepts, to do this, students need to have proficiency in a range of things. Things like simple calculations, and one of the things is mental strategies, and they spend a lot of time in primary school trying to develop mental strategies. The reason these are important is if you have mental strategies, you don't have to attend to those tasks with your cognitive labour. It's a bit like this. When you were learning to drive, you had to concentrate on what you were doing with your feet, what you were doing with your hands, and all those things. You had limited capacity to look out the windscreen and attend to all the perceptual field. So it was important that you became automatic in your footwork and your handwork and your steering and those sorts of things. So all your attention from your brain could go to looking out into this perceptual field, what's in front of you, and responding. You don't want to be in a dire situation where you're all of a sudden thinking, oh, which foot goes on the clutch, oh, hang on, you will drive automatics. All those sorts of things. That needs to be automatic. And it's the same with kids with their maths. We want them to be able to do things in their head really quickly, like basic additions and subtractions and multiplications. Not because they're little tricks, but because if they can do those things quickly, they don't have to think about it. They do it and they can attend to the more complex mathematical tasks in front of them. And they need to understand place value. So that's easy for the ones, the tens, the hundreds, the thousands, the 10,000s, that sort of thing. But also decimal place value on the other side. They need to be able to choose the appropriate calculation to solve a problem. And there's some really interesting examples from research where they gave students problems and asked them to find the answer. The strategy most of them learned, or a number of them learned at school, was if you get a big number and a small number, then you multiply them. If you get two numbers or three numbers which are about the same size, you add them together. And the context of the problem had no bearing at all. There was one famous problem where it said a 747 jet flies at 700 kilometers an hour for 2 hours. How far does it travel? Now the most common answer was 1,449, because the kids thought, well, there's three numbers here, I'll add them together. So the 747 was a number, even though we all know it's the name of a jet or a plane. They saw it as a number, so they thought they should use it. So all those sorts of things, knowing the appropriate calculation to use, being able to estimate what would be an approximate answer, being able to see if it's a reasonable one. Many years ago, I was the chief examiner in an exam, and we gave one question which was a trigonometry question, and it had a Ferris wheel in it. And the question had a picture with the Ferris wheel and a little carriage about, let's say, 3/4 of the way towards the top. The Ferris wheel had a radius of 9 meters. And the question was, how high above the ground is the carriage? And the kids had to use trigonometry to work it out. Now, interestingly, a lot of them did the calculations correctly, but didn't press equals at the end. And they got an answer which was something like negative 0.23 or something like that. And so they wrote it down. They never thought, is this a reasonable answer to give? They didn't look at the picture and said, oh, well, the radius is 9 meters, so it must be somewhere above 9 and somewhere below 18. So they just wrote down the answer. In other words, the Ferris wheel's got a bit of speed up, it's let go of the carriage and buried it 23 centimetres under the surface of the Earth. So just knowing those things is important. Estimating the answer before you start is really important. So when the kids get a problem, they should try and, the first thing they should try and do is say, okay, what do I think roughly the answer is going to be? Does it make sense? And the other thing is you need to understand there's usually many ways to get to the solution. So this is not about just teaching kids to learn the one algorithm. So I'm just going to go through briefly addition. Hopefully the kids have got a lot of this before they come, but you may need to fill some of these gaps. So addition is always about joining. The phrase you often hear is part plus part equals whole, or part plus part equals total. Right? It's always about joining. There's no other sort of addition problems. It's always about joining two sets together. How should you start? Well, the answer to this will be the same for any of these things. You always start with the concept through everyday real life experiences and problems. So if you had grade 1, and I realise most of you won't have grade 1, it might be, there are 3 birds sitting on the fence. 2 more come and join in. How many birds are there altogether? Now kids could answer that before they can do 3 plus 2 equals 5, because it's a part of their conceptual understanding of the world around them. And then 2 plus 3 equals 5 is an abstraction from that reality. We always start with something concrete or real life. And to be honest, even if I'm teaching advanced concepts in high school, even calculus in year 11 and 12, I would try and start with some sort of concrete example for them. So in addition, you'd always start from counting forwards, counting on from numbers, those sorts of things, and then building mental strategies and basic facts. Right, so these are the things you want them to do automatically. You don't want a kid to be solving a complex mathematical problem and part of the solution is 23 add 17. You want them just to go, that's 40. You don't want them to sit there and go, oh, okay, hang on, 23. Blah, blah. Right? You want them to be able to attend to the more complex task, the mathematics involved. And then you want to move them on to abstract representations and possibly algorithms if necessary. Certainly it's good that they see the algorithms and try and understand what they mean, not just as a trick to get the answer. You should note that something like 37 add 46 is much more difficult than 145 add 313. The reason being, if you're going to look at it, is with the first example, the 2-digit numbers, they're only 2 digits, but the 6 and the 7 gives you 13, so you're going to have to rename that 13 as 3 and use the 1 on the tens column. Whereas the other one doesn't involve any renaming, so it's easier, even though the numbers are longer. And the clickers. Okay, the clicker's not working. Hang on a sec. Now, the other thing is in addition, the commutative rule holds. In other words, the order of the numbers doesn't matter. That's not the only rule that holds, but it's an important one to know for a range of things. Okay, for subtraction, now addition was always one thing, it's joining. Subtraction, on the other hand, there are 3 types of subtraction. Something we might call a takeaway, something that is about comparison, and something which has missing addend. I'll give you some examples. These are all represented in different ways. So for example, something as a takeaway would be, I have 26 lollies and I eat 14, how many are left? That would be called takeaway. It's not a technical term, obviously. But we've taken some away from the whole. So if you were trying to do this with materials, let's say lollies, how many lollies would you have? You'd have 26. And then you'd eat 14, but you'd start with 26. The problem would have 26 lollies in it. Now, the second one is also a subtraction sum. It's a comparison sum, but it's not a takeaway. All right, I have 26 lollies and you have 14. How many more than you do I have? Now the answer is the same, 12, but it's not a takeaway. But it does have a couple of typos in there you might pick up. If you were trying to represent this with materials, how many would you have to have? Well, I'd have 26 and you'd have 14. So there's 40 lollies for this sum. All right, the first one had 26, this one starts with 40. So you can see it is a subtraction sum, but it is different from a takeaway. And here's the third sort, which is called missing addend. I have 12 lollies. How many more do I need to get to 26? So in this case, it's still a subtraction sum, but it is not a takeaway and it is not a comparison. And if you wanted to represent this one with materials, you would have 12 lollies. So the first one would have 26, the second one would have 40, and the third one would have 12. For us, relatively easy, we can see all this as straightforward, but you can see how some kids might be confused by those. So, how do you start? Well, the same as we started with addition. You'd start with understanding of the concept through everyday real life experiences and problems. And I'm going to say this for all of them. And in this case, the commutative rule does not apply. Okay, 26 take away 14 is not the same as 14 take away 26. The order does matter. Okay, third one, and the fourth one, multiplication and division. Again, you're hoping most of this is done through primary school, but if you have to catch it up, here's some background knowledge for what it's about. So again, with multiplication and division, you'll again start the concept through everyday examples and real life things that the kids could relate to and connect with before you do abstractions. Multiplication is really just repeated addition. Okay, so 3 times 8 is just 8 plus 8 plus 8. And that's a way of starting. It's a quicker way of counting. Instead of counting all 24 of them, you can count them in 8s. Often you can use arrays so students can see it. So in this case, you'd use an array of dots or something like that, which is 3 by 8. And in multiplication, the commutative property does apply. In other words, 3 times 8 is the same as 8 times 3. You can see that if you do arrays, because one will be 3 by 8 and the other one will be 8 by 3. But if you turn it around, you can see they're the same. Division. Division could be seen as the concept of repeated subtraction of equal groups. It comes in two forms, sharing and grouping. And in this case, the commutative property does not apply. Okay, so 24 divided by 3 is not the same as 3 divided by 24. One of the things that's really useful is if the kids can see the connection between multiplication and division. So you might teach them at the same time, the whole family of facts. 3 times 8 is 24, 8 times 3 is 24, 24 divided by 8 is 3, 24 divided by 3 is 8. They can learn them all at the same time. All right, a final challenge to think about. I'm going to work on just the standard multiplication, 32 times 14. And on the right there, you can see I've done it as you probably learnt at school, using what was called long multiplication. Now, first of all, I should say, if I was teaching my class, I wouldn't want them to do this by long multiplication. I'd want them to do it in their head, and I'd expect them to do it in their head. But I'll put it there for reference. Now, at one point I had an exchange student from Singapore, and he said, oh, I do it like this. And what he did was he said 32, and he drew that picture you can see there with 3 lines and then 2 lines, 32. He then did 14 on the top like that. And then he went, there's 8 intersection points there. There's 12 and 2 intersection points there, and there's 3 intersection points there. And he said, therefore, the answer is 448, which is correct. Now, he got that by the 8 goes straight to the end. The 2 and the 12 makes 14, so he put the 4 in the middle and added the extra 1 to the 3 to get the 4 for 448. And you can see that both methods here work. So my question to you is this: why do these methods both work? How are they the same and how are they different? Can you compare them? This is the challenge I gave to I had 2 students in my class who, this was just a young class and they were a little bit ahead. So I said to the student from Singapore, well, this is how Jeremy, the other boy, did it. Can you make sense of that? And I said to Jeremy, here's how the Singapore student did it. Can you make sense of that? So you might want to have a look at those and see if you can work it out yourself. In fact, works for 3-digit multiplication as well, or even more if you're tidy enough, if you're able to draw your lines tidily enough. Anyway, this is just some background about basic number. I hope it's helpful for you, because you need to understand where you, first of all, most of your students are coming from, and some of them who might need remediation in some of this area. And next week we're going to look at some of the number work that you need to do in junior secondary as well. Okay, well, I hope you're doing well. This is 2 weeks in, and all the best as you start thinking about your assignment and trying to find that student you can work with on that task. Okay, all the best.